So this video is about RMS. The abbreviation for RMS is root mean square. RMS value is like taking average of a square. The amount of DC current applied so that the power, which is V into I, which is equal to I square R for a resistor, is same as that of an AC signal. So here I'm using a simulation software called LTSpice. I have a 9-volt power supply and a resistor of 1 kilo ohm. If I run this, and if I hover over the resistor here, on the bottom of the screen you can see that the dissipation power, that's the dissipation power of the resistor, is 90.9 milliwatts. And next to it is the DC operating point, which is the current, is 8.9 milliamps, and the symbol is negative because the simulation software allows only the current to flow in opposite direction, so that's why the negative symbol there. So if I click on VIN, it shows me a constant 9-volt supply, and if I click on the resistor, it gives me, I'll just change the color of the wave because blue is not visible. I'll change it to red, so that's more visible. And if I go on top of it and control and click, it gives me the average also. Here I'm running a dot tran simulation. A dot tran simulation is a time-based function that tells me the amount of time that I want the simulation to run. So next I'm going to feed a sine wave. For that I should right click on the power supply and click on the advanced option, and here choose the sine option. The DC is 0, voltage is 9, frequency I'm gonna go for 100. So if I run this again, I have two waves, that's the VIN and the current IR1. So as I said, power is V into I. So if I multiply that, so control and right click pops up this window. So the VIN option is already there, and I just need to multiply that with the current of the resistor. So that's the multiplication symbol with I times R1, that's the resistor. So that's the green one there. I'll delete the red one so that only the green one is visible. So if I do control and click, I'm getting the average as 40.32, and so the calculation for that is, see, the average is I square R, and I square R is, as you saw, is 40 milliwatts. And if I have I square on the left side and I'm bringing R to the bottom, though my resistor is 100 ohms, that's 1 kilo ohm, so the watts here becomes V into I, and then I square becomes 40 micro amp square, and then if I divide that I'll get 40 microamp square, and I, the square it goes the other side, and then that's square root of 40 microamp square, which is equal to square root of 40 microamps, and taking the square root of that, I'll get this, the RMS as 6.5 milliamps. So if I click on the resistor again, I got my resistor value here. I'll change this to red again so that it's visible. So if I do control and click, I'm getting the RMS value as 6.35 milliamps, as we just saw on that slide. Thank you.